Next up is Caerus Sensors, built to combat the spread of forest fires and their devastating effects. Caerus Sensors are always on standby. Using long-distance radio technology and heat sensors to pinpoint emerging fires, Caerus Sensors will alert authorities more efficiently than traditional human surveillance. Perfect for the large landowner needing to protect their assets. Caerus Sensors, revolutionary fire detection systems built to protect the wilderness. And with that, I will now turn it over to Mr. Wynn and Caerus Sensors. Mr. Wynn.
Hello, everyone. We are Caerus Sensors. I'm Matthew Skaggs, project head and system support. The rest of my team is Tapas Carr, developer, Brandon Hill, and Jay, system support. Hunter Moses and Hernan Salas are also business developers. So next slide. So the frequency of Western U.S. wildfires has increased by nearly 400% since the 70s. California, Colorado, Arizona, and New Mexico experienced the worst of the damage. California alone suffers billions of dollars in damage to wildfires every year, damaging property and the economy while simultaneously putting people's lives in danger. In 2017, you spent $9 billion to put out fires nationwide. Firefighting alone consumed 52% of its budget, leaving less than half for research development, employee pay, facility maintenance, and improvements. This strain on the budget limits what the organization can do when it comes to new technologies and maintain the parks and forests that they oversee. Next slide. So these fires are burning more and more land on average, as you can see on this chart, and they're also burning for longer than they have in previous years. This leads to fires being more and more expensive to fight, and more firefighters having to put their lives on the line to fight them. Even with our best efforts, once a fire reaches a certain size, fighting it becomes exponentially more difficult, and making sure that all civilians are moved out of the way becomes very difficult. So next, I'm going to show you a quick video from a police officer trying to evacuate people from the path of a wildfire.
Oh.
Hey guys, walk towards the left. Are they coming for us?
Come on.
Watch out, watch out. Yeah!
So this wildfire was named the Camp Fire that caused 85 people to lose their lives. 153,336 acres burned and 18,733 buildings destroyed, and it cost the taxpayers $16.5 billion after it was finally stopped. Wildfires can become almost unstoppable once they hit a certain size. So the key is detecting and reporting fires before they ever have the chance to become unstoppable. So what Caerus presenters want to talk about today is the next step in wildfire detection and prevention. So what are Caerus Sensors? The Caerus Sensor project is basically a series of sensors set to remotely monitor designated areas to alert people of possible wildfires before they get too large. Caerus hopes to help protect the people and ecology of our nation and others in a smart and resourceful way. Over the course of our presentation, we hope to share a bit of our vision with you. Now, I will pass it on to Hernan.
Hi, I am Hernan, and today I'm going to talk a little bit about our value proposition. So again, following what Matthew was just talking about, what are Caerus Sensors? Well, there are revolutionary new fire detection systems. These sensors are designed to help put a quick end to fires that may start on large, privately owned land. Our fire detecting sensors will allow customers to easily detect the fire based on a predetermined location on their land. So we will use the customer-specific land topography to strategically place each sensor. The sensors will relay a radio signal to our servers, and we will use that to alert customers, if necessary, local firefighters. Our custom heat sensing technology means power consumption is not an issue. These devices will only consume power when sufficient levels of heat are detected. So basically, they are always on standby, but they don't consume power. So next slide, please. And I'm going to briefly talk about what sets us apart, our product's key features, and our partners that we will need to make these sensors. All right, so on to key features. The sensors will allow the customer to receive an immediate notification or phone call when a fire is detected. Each sensor is replaceable, and losing one will not bring down a system or a grid of sensors. So this means, for example, if you run over one, or maybe someone just runs away with one, you'll still have our service up and running. So these sensors use reliable, proven technology with long-range capability for forest use. No external power sources means no power consumption is required either. So the sensors each have batteries, but the sensor's not going to use those batteries until a sufficient level of heat is detected. And another feature, more of a service on our end, with our subscription plan included, the customer will receive installation, biannual inspections, and 24-hour tech support. And in order to make these sensors, the parts that we will need, such as the batteries and the pies, for the purposes of economies of scale, the partners that we will use initially are those such as Allied Electronics, video game and electronics suppliers. And these are companies located in Houston and Dallas areas. So they're not too far away. They're within reach. And they are distributors. But we hope to eventually reach the manufacturer with enough bulk orders to minimize costs by about 10 to 30% per unit. Now I'm going to talk briefly about customer segments, our customers that we will be targeting, and how we will reach them. So our target customers will primarily be large landowners located within the US. We will first introduce our sensors to those whose lands include large forested areas. They will benefit the most from our fire detection systems. Reforestation is costly, even in wildfire-prone regions, even when they receive government-assisted programs. Our product will offer a more efficient and accurate way to locate wildfires as they emerge. All right. And I'm going to talk briefly about this map here. So as you can see, over 50% of forest land is privately owned in the US, and there are about 11 million private forest owners. And as you can see, there's plenty of people that would at least consider our product. All right, next slide, please. All right, so for customer relationships, we will aim for a niche market, so we believe that will require dedicated personal assistance from the point of sale and onwards. Since each client will require a grid of sensors based on land topography and desired coverage, this dedicated approach will ensure that each company representative is completely knowledgeable about the landowner's unique system setup and any changes or updates. With a product that could save people millions in wildfire damages, building trust effectively will be a priority. We believe that a dedicated personal assistance approach is the way to do this. So how will we get our product out to our customers? We will use a direct distribution channel to cut costs, maintain better customer contact, and easily keep track of our sensors. We will rely on testing, referrals, testimonials, and early adopters to reach our target audience initially. We will follow up with newsletters and notifications to try and bring more users in. A smaller market size should allow us to provide an efficient speed of service since we will start locally. We will provide customer support, consultations via our website, phone, and email. After receiving a topographic map from the customers, our installers will arrive to install our products and does not have to worry about anything else. All right, next slide, please. All right, so I'm going to mention one of our competitors. It's Lobelium in Spain. Led a similar project with a budget of about 90,000 euros a few years ago. Not much else was heard from them. Their sensors were very costly. They used GPS technology. They were always on, and they measured whether there was a fire or not through levels of gas levels, basically, while we're using heat sensors. The solar panels alone would have cost about what our Pi costs that we use in our devices. So we don't believe they're really a noteworthy competitor. Okay, next slide, please. All right, so now I'm going to hand this off to
Alrighty, everyone. So my name's Hunter. I'm going to be talking about the service model. We are using a service model very similar to that of ADT, Amazon, and even Google Nest. And really even the most similar would be Suddenlink's service model. Basically, the customer will purchase the product, and then Caerus Sensors will provide monitoring service with a subscription fee. Next slide, please. So the cost per sensors, we have it broken down right here for every each individual part that we need on there, and it totals $118.52. So that is effectively what it will cost for us to make the sensor. Next slide, please. So our fixed costs right now, we've estimated a total of $339,209, which covers our office lease, our utilities, our research and development, new equipment, our tools, our insurance, advertising fees, and our administration salaries and IT salaries to total that one cost. Now our variable cost for sensors, including cost for the sensor and the shipping, is $128.52. Now with that, and then how much we intend to sell the sensor for, and our revenue on them individually, gives us a break-even point of 4,746 sensors in order for us to break even. Next slide, please. Now, our maximum production capacity right now is 2,400 sensors per year. This will effectively allow us to break even in about 22 to 25 months. As long as we have an average customer buys 5 units. Now, I do want to mention our units is not a one-to-one relationship. It is more of a 10-to-1 relationship. So 1 unit is 10 sensors, or 1-to-10 relationship. And so as long as we are selling our 50 sensors, as far as the average customer buying 50, then we would be able to break even within 22 to 25 months. Next slide, please. Our revenue streams. Our service fee will run $100 a month per unit, so that's for 10 sensors, and it will incrementally scale as customers purchase more, in the same way that Suddenlink would sell you internet service packages. They give a $10 increase per tier that you go up in, and we would do something very similar to that. This service fee will include product maintenance, 24-hour notification monitoring, and a biannual product inspection. We really want to push the inspection because we know that we're going to be dealing eventually with people that are like insurance companies. And since we're dealing with large amount of land, a lot of people's assets and money, and the insurance companies, we want to make sure that we are covering our parts as well, to make sure that all the products are functioning properly. The sensors will be sold at $2,000 a unit. We want to sell it as packages, so they would buy 1 unit and they'd get 10 sensors out of that, and they can buy as many units as they would like, but it would be in a 10 sensor increment. We would make a profit per unit of $714.80, which would be about a 35.74 profit margin. Next slide. Thank you. Our future partners that we're looking at right now are very limited. We want to look at security companies such as ADT. And then we also, our end goal is to outsource the logistics and essentially sell the company, since we will be working with a high risk product in the sense of, working with people's money and their assets, meaning all their land. We want to make sure that we are enabling ourselves to be able to effectively work out these logistics. And so we have noticed and found through different people advising us that eventually selling out would be a good idea. Next slide, please. So if you'll go ahead and click that link for me, this will take us to our website. It's called caerusfds.com. All right, so this is our website, Revolutionary Fire Detection System Protecting the Wilderness. It shows that we are always ready. We have stored maps, and which would be their topography, and then our 24/7 tech support. And then at the very bottom, you're also able to submit your email, your name, and a message or comment for us that you'd like to leave, and submit that, and then we can give you feedback as well in the future. Alrighty, next slide. All right, now we're going to talk about the functional and non-functional requirements, and I'm going to hand it off to my partner, Tapas.
Hey, so let's talk about the functional and the non-functional requirements of the product. In the design aspect of the product, it is supposed to be really easy, and because of that, there are no use cases that a user would interact with the product, because the product, like the first point mentions, it has to detect fire in real time. And this is one of the most important functions for the product, because if you let the fire go for too long, then it gets to a point where the fire cannot be contained. So as a user of our product, you want to know as soon as possible when the fire hits the sensor and sends the signal to the base station, so that you can be notified. Another function that our product it has to encompass, I guess, so to where two different sensor units should be able to send 2 different ID numbers to the base station, because that helps us determine the exact location where the sensors are located. So let's say one of the sensors is installed in the backyard, and another sensor is installed in somewhere different part of the land. Then based on the ID number, our operators would be able to know from exactly which location the signal is coming and where the fire is set off. Another feature that we provide to our clients is they can customize where the sensors are going to be set up. So that way they get to decide which is the most valuable possession to them, or where they would like the utmost amount of security in terms of fire detection on their property, because we're talking about acres and acres of land, and I'm sure there would be priority based on the amount of asset that our client would have. And then we move on to the non-functional requirements that we would like to integrate with our product somewhere down the line as our business grows. So the final prototypes are supposed to be designed in a way where we take into account the wind speed and how fast the fire is going to grow based on the land, and put all of that research into the product and spread out the sensors in a way where they can efficiently detect the fire as soon as possible. And we're also planning on having a website that will track all the sensors that have ever been installed on our clients' properties in real time. And again, this cannot be stressed further, that real-time data is, and real-time signal is the most important part of it, because you want to know as soon as possible the fire hits the sensor, and you want to do so. You want to take measures to stop that before it gets out of hand. So then I would like to talk about the applications that I use in the next slide. So when I was setting up the product, I had to use several applications to get the prototype working. So I started from SD card formatter to format the SD cards needed for the Raspberry Pi. Then I used Etcher to flash the Raspbian OS on the SD card. Then I used Python 3 to run a file called transparent.py file. It's a Python file, which enables the Raspberry Pi to send the signal out and to the receiver. I also used a Unix-based environment, which helped us automate this process. So as soon as the fire hits the sensor connects and sends out the signal, and you will see that further down in the video, that it's all automated, and there's no user interaction needed in there. And then there's another essential piece of software that we had to use in order to check and see our product and if the prototype is working, and that was called SSCOM. And SSCOM enabled us to see the ports that were talking to each other and what kind of data, or what kind of string data in our case, they were trying to send, as you will see further in the video. These are the softwares used for our prototype. The first one was Raspberry Pi Model 2B, which is going to send out the Pi number, or the sensor ID number. And then there is the SX1262 LoRa hat, or the long range hat with antenna, which covers the distance up to about 5 kilometers in every direction. We have 2 CC battery holders to hold the 4 C-cell batteries, and so that we can make it wireless. And then 70 degrees Celsius bimetal strip sensor, which is going to sense or detect the fire. Then we have a case to encase the whole system in order to save it from wild animals or natural, like other natural disasters or complications that could arise. And this is more important for the system to be intact before sending the signal, because the system only has to last, at least has to last until the signal has gone out from the transmitter, because that's the whole purpose of the transmitter. So having a fire resistant case around it enables it and protects it from being burnt out before sending the signal. And then the software that we used for the Raspberry Pi was Raspbian and Python for the programming language. So here's a demonstration of our working prototype. You can go ahead and play it. Here we have a Caerus sensor unit packed inside a fire-resistant case with the bimetal strip sensor protruding from it to detect a fire. All parts are securely inside the box. Once the sensor reaches a high enough temperature, the bimetal strip completes the circuit, activating the Pi. Once the circuit completes, the sensor begins transmitting its sensor ID number. In this case, the ID number is 1. This ID allows the operators to pull user information from the database and to contact emergency services. Thank you. And now I would like to pass it to my colleague Jay.
Okay, so we plan to alert our customers through the use of text alerts, and these will notify them when a fire has started or triggered one of our sensors. And we were planning to create a companion app to go along with our sensors, and this would help them be able to receive notifications immediately through push notifications when a fire strikes, and they are able to also look at their units and see monitor if there's any issues with them and manage their system. And so this is a user interface we've designed for the customer. And on the far left, you can see that there's a list of the different districts that have different sensors deployed to. And these districts can be decided by the customer themselves. We don't decide that. They'll decide how they want to distribute their sensors that they're purchasing. And they can place their sensors in different locations, even different street addresses or whatever. And below that, we have, obviously it's green, so no alarms there. And so in the middle, you can see that this is what a customer would see if they were to open this app during a fire alarm that's gone off, and the districts that are affected will be highlighted in red, and the interface will turn red itself to reflect this issue. And so on the far right, you can see that it lists all the units, and this is if the customer wanted to look into the district that was affected and see what specific units are being affected. And this could be helpful in showing the progress of the fire within that district itself. And I'm going to pass this off to Brandon.
All right, thank you, Jay. All right, so I'm Brandon. I'm going to be talking to you a little bit about the technical specifications and what makes our sensors talk. Our sensors broadcast on the 850 to 930 megahertz frequency. These transmitters we are using have a range of about 5 kilometers set before, with the system being run by its quad-core CPU. Next, please. Cool. And as we see, some of these frequencies are restricted or currently used, but many of them are open and free to use, or can be accessed with certain certifications. What I'd like to talk about now is, in general, let's talk about this real quick. As we can see, the cellular networks operate at 850, so that's a no-go. Public safety agencies use 851 to 854 or 854, but the 902 and the 928 megahertz is open. And then a few of those inside of that are locked behind certifications from radio classes, which we hope to obtain in the future. Other things we'd like to do is communicate with local state governments or even the federal government to try to get certain areas sectioned off so that we can use normally restricted radio frequencies to help, broaden our area that we can talk in. So next slide, please. Cool. What I want to talk about next is how we're actually going to set these sensors up in practice in the real world. Together, we all came up with 2 main methods for deployment. First up is the left picture, it's the green one, showing a fire line method. This method has the benefit of requiring less sensors, but covers a smaller area. The use for this one would be safety fire lines to detect if a fire is in a location or headed towards a certain high-risk area, such as housing or large dry wooded areas that might fuel the fire and in turn make things worse. The fire line sensors will be in a proximity line. They're a little closer in the image than they actually look. This is a zoomed out picture. But behind it will also be a small grid to make sure that if any fires are blown by the wind over the fire line or any such factors like that happen, we'll be able to maintain the fire line and still detect if the fire's jumped it. The second one on the right, the grid pattern, it requires more sensors but can cover a very large area. The grid is exactly how it sounds. It's a grid of evenly spaced units, or like said before, when we look at the topography, if chosen, we'll change that grid to a tighter or a wider grid. But it can detect fires that form early on and alert monitoring stations to its location, along with a view of the direction the fire is spreading and its general size, going off by how many sensors are going off and in what direction those sensors are. Issues that we foresee in the future would be interference with too many sensors alerting at once. To get around this, we plan on implementing and testing a software for the sensors that alternates signals to allow other devices to communicate in times of silence. Once we have more sensors in for prototypes, we'll be able to actually test this out instead of just having the theory. We also plan on making use of the wider range of frequencies, and like before, we plan on communicating with governments to see if we can't get a designated frequency for Caerus sensors. Also in the future, we'd hope to be able to come up with new models with help from professional firefighters and agencies in preventing wildfires to throw their hand in and see if we can improve the system. Next slide, please. All right, and the last thing I'll talk to you about is going to be the local database. Our local database uses a combination of Linux, Apache, MySQL, and PHP. The computer containing the local database will be connected to the database on the cloud via MySQL Workbench. This local database will include the sensor, the sensor number, the latitude, the longitude, the customer name, phone number, email, and location. All the data that we need to make sure to contact the right authorities and the customer in case of an emergency. For location, these properties might be so big that it is convenient to slice them up into those districts that we're speaking about just a moment ago. The customer would be able to choose which parts of his property he would like to name what, so that if we told him District 1 was on fire, he would know without having to look up where that is. The location of the field will be named by them. When a sensor goes off, a worker will go through the database using that sensor number as the key to find all that information to tell that there is a fire at that particular property at any given time. Whenever we contact the customer or services as required. Next, I'll pass it back off to Mr. Skaggs to continue talking.
So for our database on the cloud, we use Amazon Web Services. The engine we use to learn our database is RDS MySQL Community 5.7.22. We also needed a EC2 instance to access it. So this instance uses SSH and sets the security rules for accessing the database. So SSH encrypts our connection with the database. So SSH is basically like a VPN for your computer, except we are using it for our database. So one problem I encountered setting up the database is that I had to edit the inbound rules to allow all IP addresses to access this database. So in the future, we will only allow certain IP addresses to access the database to prevent this. We will also require a username and password and a private key file to access this database. There are two tables in our database: sensor information, which is sensor information backed up from the local database, and sensor alerts, which keeps a log of all the times that the sensors have went off. Next slide. So here's pretty much what our database looks like. So the sensor information table contains all the information from the local database: sensor number, latitude, phone number, location, and address. So in our video earlier, pipe number one went off in the video earlier. So we will contact the authorities and the customer, John Doe in this instance, both through the app and by phone when a fire occurs. So next slide. So the sensor alert table is basically a log table of all the times that the sensors have gone off. So each alert has a log number associated with it, which auto increments every time a new alert is inserted into the table with the sensor number, date, and time. So as you can see, we were testing this out with different ways to timestamp our alerts as shown in the table. Next slide. So our sensors will send a basic string message, as you saw in the video, of just your sensor number to a local data center, which will get there by going through relays that are set up less than or equal to 5 kilometers away from each other. The data center also has a copy of alerts on their database, and they also send that copy to the cloud database for redundancy purposes. So we send data via MySQL Workbench using the following commands, as you can see. And in the commands, we select the table from the schema we want. Then we insert the sensor number and a timestamp of the current database server time. So now I'll pass it on to Jay.
Okay, so for a backup plan, we basically want to emphasize redundancy, because if we get taken out, the fires are still going to keep going. So we want to make sure that we have as many backups as possible and as often as possible. And so this is reflected in our plan to have 2 automated backups, and then just in case we'll have an employee do 2 manual backups. And the automated backups will happen basically every day and will be uploaded to the cloud. And for manual backups, we'll be having them back things up every 7 days, and they'll back it up on a local device also. And then for retaining this information, we plan to keep it around, for the daily ones, we'll go around 7 days and then replace it with the latest ones. And then for the entire database, we want that to have at least a 90-day retention. And then what we need to go live really is for us to have the materials to produce an amplifier system. Because right now our sensors, they can go out pretty relatively far, but we need something that can allow us to have one command center and then expand to multiple different sensor groups. And these amplifiers will help us be able to do that. And so, as you notice, it requires a solar panel for that system, and that's because these amplifiers will be actually on during the whole time that they're deployed, and that's because they need to be on to detect a signal from the pies themselves. If there's any questions, we are ready to accept.
I had a question about your decision to go to the to be a service instead of a product. You know, you talk about having the 24-hour service, almost like a like a security system, just like the last group when I was talking to them. Wouldn't it be more effective, cost-effective wise, because you wouldn't need the employees and everything, to just build the product itself and sell it exclusively to, you know, farmers with large ranches, fire departments specifically, you know what I mean? Maybe you could, you know, have a couple of laborers that would actually place the product in the specified areas, but instead of having to amplify it all the way to wherever you're receiving it on the radio frequency, it could amplify it just to, you know, the local fire department or the farmer's house or his cell phone or something like that. You know what I mean? Instead of y'all monitoring it, you just make the product, distribute it, and then they're in charge of monitoring it.
That's a good question. A lot of it has to do with insurance companies. Since this is going to be dealing with people's assets, like, you know, their land. When I had talked with the mayor of Tyler about this whole product and ideas, he mentioned to me one specific thing. He said, you have to make sure that you are following specific guidelines and so that you don't get sued. At the end of the day, if your product fails to work and you're not monitoring it properly, you know, the things aren't working properly, obviously insurance they're gonna cover the people whose product or stuff was damaged or whatever, but they're gonna come after us because all of a sudden, you know, now they're having to pay all of these things, all this money over to the people are insuring, and then they're gonna sue us for it. So we wanted to make it a service so that we're actively monitoring, we're covering our end, and so that we can make sure and certify for the customer that their products are always working.
Okay.
And it is expensive. Don't get me wrong, it's very expensive. And so we felt like we could end up making more, you know, more revenue off of this, having it as a service rather than like a one-time thing.
Right.
And I would also like to add on top of what Hunter was saying, that it's mostly due to the complexity of our product, that why we would monitor it rather than just handing it out to anybody. That's mostly why. And also legal compliance, the radio frequencies, those are something that we have to stay on top of. And although the devices are customizable, we have to work within those ranges that the government gives us.
Yeah, I would also like to add to that. Aside the legal aspect of this product, it's just that our customers are going to be busy people, and they're probably not going to want to sit around and monitor the sensors go off the whole time. So it's better off if you just let someone else handle it, and they take the best care of your assets, given that you buy our services. You know. So, and also because there's going to be a lot of research and development going on with the product, we plan on automating some of the other stuff, like we plan on automating the 911 call, or contacting emergency services. Then explaining that side of the technology is also another step that we have to take with our clients. So it's we just thought it would be better off if we did the whole process, and we just sold the whole package to our clients.
Okay. No, I understand that. It was just I had this thought process of if you became sort of industry recognized, you could sell the product to fire departments, for instance, governmentally recognized, and then create your own trainings on how to do everything on it, and then it could be a certification or whatever that a fire team leader or whatever at a department gets to work on your equipment specifically. It was just something I was thinking about. I'm not questioning the way you were doing things or critiquing it at all. Just something
No, I
Oh,
mean,
yeah, you had a
we
good question.
appreciate feedback.
I also have a question for Hernan and Hunter. Guys, when you were
Skaggs is talking, and I don't think that's muted.
Mr. Skaggs, your microphone is muted.
All right. Sorry about that. So what I was gonna say is basically the design of our the model design of sending a signal out and relaying it back. I think a fire department can definitely take advantage of that. They if they wanted to, we can give them all the designs for our product and they can do it. But for copyright reasons, they would have to not give out our designs. Obviously, that's the problem.
What we could also do is because we were testing out the prototype, we had a hat unit hooked up to a computer, and then we had that computer with the software for reading the message. So we could probably do something where we offer local emergency services a unit set, and then also a receiver set that they can just hook into their computer, and then they don't have to worry about anything else. So it could be sort of like an alternative product for emergency services or other large corporations or government agencies.
Josh, you had a question?
yes, for Hernan and Hunter. Guys, when you were working on the business model for this, it was similar to security services like ADT and those guys. Did you consider possibly partnering with an insurance agency to underwrite possible damages in case a sensor fails? I know that you guys are planning on just putting arrays of these out there that have a low failure rate, but is there anything that backs a landowner financially in case a fire consumes all of their property?
Yes, good question. First, we need to, when I was talking to the mayor about this and pitching this idea to him, he mentioned that very specifically. You want to make sure that the insurance companies jump on board with this, but you have to make sure the product works first. And not that it doesn't work now, but make it known to those different people, make sure they're sharing it, because then they're going to go this, is there any way we can get a deduction on our rates, whatnot? And that's kind of our way in to the insurance companies, marketing it directly to them first, with there being not very well known, not a lot of backers necessarily yet. Then they would definitely just shush us away, because obviously it's a product that who knows if it even works yet, as far as what they're seeing. So yeah, definitely something we want to do in the future is make sure that we're partnered with insurance companies to make sure that they're, either giving their, wanting this to be something that is required to use, or like some kind of regulation for it.
Okay, thank you.
Thank you.
To add on to what Hunter just said, initially that was the plan, was to market to these larger corporations and insurance agencies, but we kind of felt we had to build up that reputation before we would be actually recognized. We had to prove that our product works before people start coming claiming things at us when the product itself should be working.
Yeah. And also, like you said, we mentioned ADT and Ring and other security companies because they fall kind of under our domain of product. Like they also sell security systems. And that way, it would be a huge help with a lack of distribution channel that we have right now, that they would help us distribute this product and pretty much just get it out there to people that already take their services. So that's another way of being known as or building up as a famous company, is to just get your name out there, I guess. And those companies will definitely help us with the distribution part of it.
I think ADT would like to get an advantage over their competitors, having a system like this in place. And other competitors of ADT might like to have this fire detection system in their company. That's what I think.
Yeah.
Just as a side note, California itself, visited their website a little while back. They had a program where they were trying to find a new way to monitor fires, potentially remotely. Some companies tried to do a satellite view, but it wasn't really showing as often as the live time, because the satellites have to cross back over, outside of putting an actual geostational satellite in orbit. But they had a pretty big program trying to figure something out. Potentially in the future, we'd like to bring and offer this to them as a solution, and see if we can get any distribution channels or maybe some ways in with the California state government, through the through the insurance agencies. After we get a little bit of backing and proof behind the concept, we can take that to them. Once we get some more live real world testing done.
All right, and thank you for that. And this concludes the capstone presentations. I hope you enjoyed them, and please join us again next year. Thank you and goodbye.
Looks like there's something in the chat.